Hello and welcome to the AI Research Roundup. I'm your host, Alex, and today is May 4th, 2025. Alright, today we're diving into an interesting ICLR conference paper titled Interpreting Emergent Planning in Model-Free Reinforcement Learning, published just over 3 months ago. This paper basically asks, can model-free RL agents, the ones without explicit world models, actually learn to perform decision time planning? They dig into whether observed planning-like behavior is genuine or just learned tricks. Okay, so this first figure gives us a peek into what the authors found. It shows examples of the agent actually forming internal plans to push boxes to targets in the Sokoban game. You can see it, well, evaluating different routes, adapting its plan when one seems infeasible, and even planning forwards from boxes and backwards from targets, sometimes in parallel. It really looks like a kind of learned search happening internally. Building on that idea of internal plans, this next figure shows exactly what those plans seem to be made of. Okay, the authors found the agent represents two key concepts internally: agent approach direction, which is where the agent plans to move, and box push direction, where it anticipates pushing a box. You can see these visualized as arrows on the Sokoban grid over several steps. These concepts appear to be the building blocks for that internal search process. So how well are these agent approach and box push concepts actually represented inside the network? Well, this figure quantifies that. It shows the macro F1 scores for predicting CA and CB using probes on the internal cell states across different layers. You can see the scores are much higher compared to the baseline using just raw observations. This really confirms the agent strongly represents these planning concepts internally, particularly in deeper layers. Alright, so we saw that the agent does strongly represent these planning concepts, and this next figure gives us a look at what those internal plans actually look like. Okay, here we see the combined agent approach, the teal arrows, and box push, the purple ones, decoded from the network's final layer state. This visually confirms how the agent seems to combine these concepts to map out potential moves and pushes on the board. Okay, so if those concepts really form the basis of plans, do they actually control the agent's actions? Well, this table tests exactly that. It shows success rates when the researchers intervened, basically injecting those learned concept representations into the network's layers. You can see interventions using the trained concepts, especially for agent shortcut, are way more successful, up to 98.8% compared to random ones. This really pins down the causal link between these representations and behavior. Okay, so we've seen these concepts are causally linked to actions. Now, this final figure ties it all together, showing how the emergence of these concepts during training relates to the agent's ability to benefit from extra thinking time. Alright, you can see a clear correlation as the macro F1 scores for predicting agent approach and box push improve. The percentage of extra levels solved with more computation time goes up. This really suggests these learned concepts are fundamental to the agent's planning-like improvements. So, wrapping things up, this work really provides the first strong mechanistic evidence that model-free agents can learn genuine planning. They identified specific concepts, agent approach and box push, that the agent uses internally in a search-like way. And crucially, these concepts are causally linked to the agent's actions and planning improvements. Pretty fascinating stuff. Thanks for tuning in to the AI Research Roundup. I'm Alex. See you next time.